Ladies and gentlemen, in this lesson, we're going to talk about estimating quantities in scientific notation. We're going to look at large numbers or small numbers. We're then going to decide do we need to round them up or round them down. And then we're going to convert them into scientific notation. That way we can calculate with them and better understand them. So let's go ahead and get into estimating.
From miles away, that's getting closer every day. It's getting out of view. We'll clear the room. We'll clear the room. Punching all the
Now, for estimating quantities, the very first thing you want to do is take a look at your number. It doesn't matter if it's an incredibly large number or small number. You need to locate the largest place value in that number that is a non-zero digit. So if we take a look at number 1 and we have 37,000, well, the number that's sitting in the largest place value that is not a zero is the number 3. And now that we've located the largest place value, we then need to figure out, well, are we going to round this number up to 40,000 or are we going to round it down to 30,000? Because we're estimating. Again, our number is not going to be 100% precise because it's estimating. So to do that, we need to look at the number that is directly next to our largest place value. That's going to determine, are we rounding this number up or are we rounding it down? So the number behind your largest place value has to be 5 or larger for you to round up to 40,000. And if it's below 5, we're just going to bring it down to 30,000. So in this case, we have a 7, which means we're going to round our largest place value up to a 4, making this number then 40,000 instead of 30,000. And now that we've rounded this, we can go ahead and write our estimate in scientific notation. So to do that, if we don't have a decimal point in this number, it's always at the end. And now we need to move our decimal point to get a number that fits scientific notation protocol, which means it has to be greater than or equal to 1, but less than 10. So let's go ahead and move our decimal point one place value to the left, twice, 3 times, 4 times, and now it's going to meet that range that we need, so 4.0. The only thing that we're going to do is write our number as a single digit, so we're not going to put 4.0, we're just going to put 4. And then we need to write it to a power of 10, so 4 times 10, and the only thing that we need to figure out is what is this exponent going to be? And it's all determined on how many times you move the decimal point. So we just moved the decimal point 4 place values to the left, making our number smaller. So in return, our power is going to increase by 4. So we made our number smaller. In return, our power does the exact opposite and increases by 4. So here is our final estimate for number 1, 37,000. Our estimate in scientific notation is 4 times 10 to the 4th. So let's go ahead and take a look at number 2. Let's first locate our largest place value that is a non-zero digit. In this case, it's going to be this 4. Now let's take a look at the number that's directly behind it, which is an 8. Well, that's 5 or larger, meaning that we are going to round up. So we have 0.0000, and this will be a 5 now. And then the only thing that's left is let's go ahead and convert this into scientific notation. So again, we need to meet that range of greater than or equal to 1, but less than 10. So we can move our decimal point this time around to the right. So once, twice, 3 times, 4 times, 5 times. So we're going to have a single digit of a 5 out front times 10 to the. This time around, we went from a smaller number to a larger number. So we need to make sure that our power is going to decrease because our number got larger. In return, our power is going to get smaller. And this is going to be determined on how many times we moved our decimal point. Well, we moved it 5 times, meaning that we should have a negative 5 as our exponent on our power of 10. Now let's go ahead and take a look at number 3. Let's locate our largest place value. In this case, it's a 7. The number directly behind it is a 4, which means we're not going to round this up to an 8. Instead, we're going to bring this down to 70 million. And now we can convert this into scientific notation. So we have decimal point at the end. If we don't see it, just like we had that scenario in number 1, we need to move this once, twice, 3 times, 4, 5, 6, 7 times. So our single digit out front is going to be a 7 times 10 to the. And then again, we went from a larger number to a smaller number, which means in return our power is going to increase. So we again had 1, 2, 3, 4, 5, 6, 7. So that should be a power of 7 for number 3. Now let's go ahead and jump down to number 4. We need to locate our largest place value, which is a 2. We can't round this because the number behind it is not 5 or larger. So we have 0.002 or 2 thousandths. Now we need to convert this into scientific notation, our estimate. So we're going to move this once to the right, twice, 3 times. So this will be 2 times 10 to the negative third, just like the scenario we had in number 2. And then finally, our very last one before we move to the practice session where you try out 5 on your own. So let's go ahead and take a look at our largest place value, which is this 1. The number behind it is 5 or larger, meaning that we're going to round our largest place value up to a 2. So our new number is going to be 200,000. Now we need to make this into scientific notation, so decimal points at the end. We're going to move it once, twice, 3 times, 4 times, 5 times. So this will be 2 times 10 to the fifth. Again, making our number smaller. In return, our power increases. Now let's go ahead and make our way over to the practice session. Now it's time for the practice session. I want to see if you can estimate these quantities, these 5 questions, and estimate them in scientific notation. So I encourage you to pause the video here, try out all 5 questions on your own, and when you think you're ready to go, come back and play the video and see how you did. So I'm assuming at this point you tried out all 5 and you're ready to go over the answers. So let's go ahead and take a look at number 1. Again, you're trying to find the largest place value that is a non-zero digit. So for number 1, that would be the 7. Then you need to look at the number behind it, see if it's 5 or larger. In this case, it's not. So we need to put 0.0007 as our rounded value because, again, you're not moving it up to an 8 because it wasn't a 5 or larger. Now we just need to write our final estimate in scientific notation. So let's move our decimal point to get in that range of greater than or equal to 1 but less than 10. So once, twice, 3 times, 4 times. So 7 times 10 to the, and you should have it to the negative fourth, because again, you're going from a smaller number to a larger number, and in return, your power does the opposite and decreases. So this is our final estimate in scientific notation for number 1. So if you got 7 times 10 to the negative fourth, nice job. Let's go ahead and take a look at number 2. So we have 128 million. We find our largest place value, which is a 1. This is not going to round to a 2 because the number behind it is not 5 or larger. So we have 100 million that we're working with. We then need to convert this to scientific notation. So let's move that decimal point. Again, it's at the end if you don't see it, and get into that range. So once, twice, 3 times, 4, 5, 6, 7, 8. So this will be 1 times 10 to the positive 8, going from a very large number to a smaller number. In return, the power does the opposite and increases. So final answer as an estimate, 1 times 10 to the 8th for number 2. And then on to number 3. So largest place value is an 8. The number behind it meets that criteria of 5 or larger. So we have to round this up to a 9. So 0.009. And then we can convert this into scientific notation by moving it once, twice, 3 times. So we get 9 times 10 to the negative third for number 3. And then moving down to the final 2, 274,000, we have the 2 as the largest place value. The number behind it is going to round this up to 300,000. Let's convert this into scientific notation. So once, twice, 3 times, 4, 5. So we get 3 times 10 to the, again, going from a larger number to a smaller number. So in return, the power is going to increase. So this is going to be 3 times 10 to the fifth. And then finally, the very last one, 85,129,000, largest place value is an 8. Number behind it is going to round this up to 90 million. Let's move our decimal point once, twice, 3 times, 4, 5, 6, 7. So we're going to get 9 times 10 to the 7th for number 5. If you went 5 for 5 on this practice session, very, very nice job. If this video helped you out estimating quantities and scientific notation, please leave a like on the video. Comment any other topics you want to see in the future. Subscribe, turn on that bell for post notifications, and then we'll see you in the next one with some more mathematics.